Hello, this is James at Simetar. I want to show you a short tutorial on how to estimate parameters for probability distributions using Simetar. The data I have here is 6 random variables with 16 observations. This could be done with more than 16 observations and certainly more than 6 variables. I want to demonstrate our univariate parameter estimation system, or UPES, as it's applied to variable number 1. And to do this, I'm going to open up Simetar and use theta icon, which is a univariate parameter estimator. And I'm going to highlight my range of data, which is just one variable. We have to do this one variable at a time. I'm going to choose the maximum likelihood estimation procedure, and I'm going to ask Simetar to generate the equations to generate random numbers for each of the distributions that I'm going to test here. And yes, there is text in the first. Simetar will check you on that. Now this is the result you're going to get with Simetar. It's going to test these different distributions. The negative binomial doesn't fit this data at all, so it's not going to have anything. If you look at this equation, each of these equations here represents, or each of these cells represents, a formula for simulating the random variable based on the parameters to its left and this common uniform standard deviate down below. See if we can check that. The purpose of that is that I can now simulate these random numbers. Oh, by the way, binomial didn't work either. So I'm going to delete it and just put in empirical. And the way I'm going to do that is type EMP, left parenthesis, use the function editor. It asks for the values. There are numbers up here for variable number 1. So I'm going to highlight those, no label at this point. And then it asks for a random number. And I'm going to specify this common uniform standard deviate down here. And after I'm through, I'm going to click OK. Now, I'm going to simulate these roughly 15 probability distributions, 500 iterations. I'm going to tell it there. I'm going to clear all this out. This is from a previous tutorial. I'm going to add these random variables that were highlighted to my workspace. I'm going to tell it to put the results in sim data, variable 1, and I'm going to simulate them. And that's it. About 1 second later, we have 500 random values for each of these. Now I'm going to do a test here. It's called CDFDEB. It's a function in Simetar. It's a criterion that compares your original data to the simulated data to see which distribution fits your original data best. Okay, so I'm going to put down the label of the simulated distribution. The first one starts in B8. I'm going to type the function CDFDEB, left parenthesis, f of x. And what it wants is a sample data. So I'm going to come over here and highlight the original data. I'm going to press F4 at that point because I want to use the same original data to compare all of these distributions. Come back over here, highlight the random values only, no labels, for the 500 random numbers we generated, and click OK. And I get a criterion value. Now, if the beta distribution had perfectly fit that original sample data, the CDFD value would be 0. Okay? And we stopped at Poisson, so there's no use going any further. We'll enlarge this just a little bit so we can see the numbers better. So what we're looking for is the minimum CDFD value. One that gets closest to 0 would be our best distribution. If we come across our empiricals, a 1.36, geometric, Poisson, It appears to be an empirical distribution fits it best, followed by the beta distribution. Now we can do a graphical test of this, see if we're in the ballpark. We can do the empirical distribution. We can do a CDF graph of the data. I'm going to go back and highlight my original variable 1, add it, and then I want to include all of the simulated numbers for the different distributions in my chart, like this. Add that, click OK. And we now have a CDF chart over here that compares our original data to all of the simulated distributions. Well, we can see that this one really doesn't fit our data at all, and we can eliminate it. If you click on this orange one, you can eliminate it also. It clearly doesn't fit our data because our data is a black line that's down in the middle of this mess of CDFs. And if we can just go through systematically and delete those, we'll sooner or later find out that the empirical distribution most closely lies on top of the original distribution. Okay, and you can proceed like that until you're through. I think that's one nice feature in Simetar. You have to repeat this UPES option for each random variable that you would have here. Now, if, for example, you wanted to use an empirical distribution to simulate all of these 6 variables, there's a feature in Simetar that will estimate the parameters for an empirical distribution 4 different ways. And so what I'm going to do here is invoke that option. Okay, so I clicked on f of x in Simetar toolbar, highlighted the 16 observations for the 6 random variables, said there's a label in the first cell. I'm going to add these, and then I'm going to do something a little more different. I'm going to tell it I want to estimate the parameters as percent deviations from trend. Okay, and this is what we get. All at once we have the summary statistics, unsorted deviations from trend as percentage, a correlation matrix of the random variable, so later we could do a multivariate empirical distribution, and I have the parameters for simulating the random deviations about trend. If I were to take the mean values down here as my center point for simulation, or I could use a forecasted value from trend, because if you look up here, we have the intercept and slope for the trend regression. So I can use the mean values, and I can simulate this as follows. Stochastic value equal EMP, left parenthesis, use the equation editor. So I want my values. These are the random values here. I want to use the probabilities, which are the fx values that go from 0 to 1. I'm going to press F4 because I'm going to use the same ones on all of them. And I'm going to click OK. This will give me a stochastic deviate for each of the variables. Clicking F2 on that, I can see that it's correct. So these are stochastic deviates from trend. My actual stochastic value I'll put down here is equal to the mean times left parentheses 1 plus this deviate. The reason I do that is the deviate is a percentage of the mean, or our trend forecast in this case. And I'm going to bring down my labels equal variable 1. And I can simulate these as follows. Now, my simulation engine has all of these random numbers that I generated a while ago. And I'm going to put these new ones in EMP. I'm going to tell Simetar that the labels are just above the random values. Click Add, Simulate, and we now have 500 observations, 500 iterations of random variables, variable 1 through variable 6. In a subsequent video, I'll show you how to do a validation of this to make sure that we've simulated this correctly. And the next thing I'll do is show you how to do a multivariate empirical distribution simulation. Thank you.